Alright, extra example for section 11.1, number 1, a fair die. So, Jenny made a 6-sided die in her ceramics class and rolled it 60 times to test if each side was equally likely to show up on top. Here are the results of Jenny's 60 rolls of her ceramic die and the expected counts. So these are the outcomes. This is what was observed, and if it were a fair die, we would expect that each side would come up 10 times if it's perfectly symmetric. So we're going to calculate the value of the chi-squared statistic, and using the appropriate degrees of freedom, calculate the p-value and what conclusions can you make about Jenny's die. Alright, so for part A, chi-squared statistic, we would do this. We would do this, chi-squared equals, and we're already given the expected, so we just do 13 minus 10 squared over 10 plus 11 observed, 10 expected squared over 10 plus 6 minus 10 squared over 10 plus 10 minus 10 squared over 10 plus 8 minus 10 squared over 10. That's how we would show all of it, and that gives us, did I miss one? Thank you. 13, 11, 6. Here's 12 minus 10 squared over 10. And there we go. And so that will give us 3.4 for chi-squared. Okay, and then part B is using the appropriate degrees of freedom. So what would the degrees of freedom be? Number of categories minus 1 is 5. There are 5 degrees of freedom because there are 6 categories, 6 possible outcomes. And then for the p-value, we would just do on our calculator, and I'll show you table C as well, but more accurate to do chi-squared CDF and do 3.4, a really big number, and 5 for your degrees of freedom. You should get about 0.64 for your p-value. Don't forget to take that extra step. And so what that means is that if, now this kind of makes a case for why you really need to carefully state what you're testing, because this means if the die were fair, so at this point we really should state what H naught is, and let's say we said H naught is the die is fair, and H sub A would be the die is not fair. So assuming H naught is assuming that the die is fair, that means if it were fair, we would have a 64% chance of obtaining the outcomes that we did in our experiment. Okay, so therefore we do not have convincing evidence that the die is not fair. So we cannot reject H naught because 64% is a very high likelihood that we would get the outcomes that we did. So let me write that out. This means if die were fair, because the p-value is the probability that something would happen assuming H naught is true. So we need to know what H naught is. This means if the die were fair, we would have a 64% chance of obtaining outcomes in our experiment that we did. So the conclusion would be we do not have. And the thing I want you to think about is, can we then say that the die is fair? Can we conclude the die is fair? And that's the important. It's important you say you don't make that conclusion. So there's a difference. You can't just say, normally two negatives make a positive, but not in this case. So we would say we do not have convincing. We haven't proven anything. We do not have convincing evidence her die is not fair. But keep in mind, this does not prove the die is fair. Does not prove the die is fair.